In this video, we're going to look at the different trigonometric sum and difference formulas for sine, cosine, and tangent, and how to use them. So you would probably on a quiz or a test be able to access these. There's no reason for you to have to memorize them. It's more just making sure you understand how to use them. So on this first example, if I want to find the sine of 145 minus 30, the sine of 45 minus 30, we're going to use this formula up here. So let's say like alpha equals 45 degrees and beta equals 30 degrees. And I'm going to plug that into this formula here. So sine of 45 minus 30 is the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. All right, let's use our unit circle, right triangles, whatever it is that you need in order to find these sines and cosines. Oops. All right, so the sine of 45 is 1 over the square root of 2. The cosine of 30 is root 3 over 2. The cosine of 45 degrees is 1 over root 2. And the sine of 30 degrees is 1/2. So we have root 3 over 2 root 2 times minus 1 over 2 root 2. And we'll have root 3 minus 1 over 2 root 2. If you wanted to rationalize the denominator, you could. You would need to multiply by root 2 over root 2 in order to do that. And we'd have 2 root 2 times root 3 minus 1 all over 4, if that's something that you wanted to do. Now, if you look, part B, you end up having, like, this is the sine of 15 degrees, and this is also going to be the sine of 15 degrees, and it just wants us to show why those would be the same. So in that second part, if alpha equals 135 and beta equals 120, then we're going to have the sine of 135 minus 120 is the sine of 135 times the cosine of 120 minus the cosine of 135 and the sine of 120. And 120 degrees would be here. 135 would be a 45, 45, 90 here. All right, the sine of 135 times the cosine of 120 minus, and then the cosine of, sorry, I have these backwards. The sine of 135 times the cosine of 120, and then minus, we have cosine of 135 times the sine of 120. And since these end up being positive, you subtract, you end up getting the exact same answer here. Here's another example. It wants us to find the exact value of the cosine of 75. Well, 75 is not one of my known angles. However, I could rewrite 75 as 45 plus 30. So if I say, okay, alpha is 45, beta is 30, let's go up and look at what our formula is for the sum sine here, or cosine. So cosine alpha, cosine beta. minus sine alpha sine beta. All right, we have these values up at the top. Oops, this should be root 3 over 2. And then a half. And it's just a kind of a coincidence, actually, that the cosine of 75 ends up being this here. I mean, if you think about it, on your unit circle, right, we're looking at sine of 15 degrees on that first example. And so if you then translate that to 75, right, like that's going to actually be the exact same triangle, kind of like the 30, 60, 90 situation. So it actually makes perfect sense that the sine of 15 degrees and the cosine of 75 degrees would end up being the exact same number, because here you're across from your 15, right? And then here your 15 is here. So it's kind of like that situation again, like the 30, 60, 90 triangle. And this would reduce to that exact same value. All right, let's look at the tangent. So if I want to figure out the tangent of this sum, let's go look at the tangent sum equation. So I do tangent alpha plus tangent beta in the top. All over, and then what's in my denominator here? 1 minus the multiplication of those. All right, these are the same triangles we keep looking at over and over again. All right, so tangent ends up being 1 over root 3 plus 1 minus 1 over root 3 times 1. So I have 1 plus root 3 all over root 3, if I change this to root 3 over root 3 to get a common denominator, all over root 3 over root 3 again. So root 3 minus 1 over root 3. And for fractions, I'm going to multiply by the reciprocal. I'm going to get 1 plus root 3 over 1 minus root 3. And then I want to show you how it would be if you did want to rationalize the denominator here. So I would multiply by the conjugate. And so I end up getting 1 plus 2 root 3 plus 3 in the top, and then 1 minus 3 in the denominator. And so I would get 4 plus 2 root 3 over negative 2, or negative 2 minus root 3. All right, let's do one final problem here. I'm going to use the difference identity for that sine piece. So that's sine alpha minus cosine beta. Sine alpha cosine beta, excuse me, minus cosine alpha sine beta. All over cosine alpha cosine beta. And then I'm going to go ahead and split up this into two fractions. And when I do that, I end up seeing that my cosine betas will cancel here, and my cosine alphas will cancel here. Sine over cosine of the same angle is tangent. And same thing here. And that ends up giving us our identity.